Topic 3, Portfolio Risk and Return. Section 2, an Introduction to Matrix Algebra. Let's talk about matrices. A matrix is a rectangular array of numbers, or any objects, in fact. A matrix with only one row, we'll call a row vector. And a matrix with only one column, we'll call it a column vector. Usually a single letter, like A or B, is used to denote a vector, or a vector or a matrix. And we're going to use the row column identifier in Excel. So when I refer to, say, item Aij, that would be the item in the ith row and jth column of matrix A. And it's going to be important to use matrix multiplication for a bunch of applications. A matrix A can be multiplied by matrix B, and that's going to be written A times B, or usually simply just AB, if the number of columns in matrix A equals the number of rows in matrix B. In other words, if matrix A has these dimensions, R number of rows and C number of columns, and matrix B has this dimension of R rows and C columns, you can only multiply two matrices together if what we say is the inner dimensions are the same. In other words, the number of columns in the first matrix are equal to the number of rows in the second matrix. So if these two numbers are the same, say a 1 by 3 times a 3 by 1, or a 3 by 2, as long as those inner dimensions, those threes are the same, you can multiply them together. Now the resulting matrix is going to have the dimensions of the outer, or the dimensions of the outer dimension. So when we multiply A times B, the resulting matrix is going to be the size of the number of rows of the first matrix and the number of columns of the second matrix. If it happens that you multiply, say, a 1 by 3 by a 3 by 1, you're going to be allowed to do that, so the inner dimensions are the same. Now that resulting matrix is going to have a dimension of 1 by 1, which is going to be a single number. And it's just going to happen that that single number is a sum product. Now let's talk about what it actually means to multiply two matrices together. Okay, so you take these two matrices, you multiply them together. That new matrix has the outer dimensions of the two matrices, and each number in that new matrix is a sum product. And what that is, it's the sum. If we multiply A times B, that item A, B, I, J, the item in the ith row and jth column of that new matrix AB is a sum product of the ith row of A, times the jth column of B. We're going to do that in Excel using the mmult function. We're going to say mmult, put in one matrix, say matrix A, put in the second matrix, matrix B, and we're going to hit Control-Shift-Enter across an area or an array that has the outer dimensions, and that's going to do our matrix multiplication. So let's go to our star file under matrix, and I have a number of matrices set up. I have matrix A, which is a 2 by 2, 2 rows, 2 columns. Notice when I highlight that area, if I look in the top left where the formula bar is, it says 2 rows, 2 columns. So that's a 2 by 2. Matrix B is a 2 by 3. I have matrix D. I don't know what happened to matrix C, but hey, I just switched to matrix D. It's a 3 by 1. And I have, in matrix D, I'm actually going to call that a vector D since it's a single column. And I also have a column vector here, vector E, which is a 3 by 1. So first thing I'm going to do, just one helpful hint here. Let me just do one thing here. I want to take vector D and switch it from columns to a row vector. So what I'm going to do is I'm going to select this range right here, and I'll say equals transpose. And what that's going to do, it's going to take vector D, I'm going to close that, and then I have to hit Control, holding Shift, and then hit Enter. So I've now transposed D, I'm going to call it D transpose, from a 3 row by 1 column to a 1 by 3 row vector. Now the reason I'm doing that is I want to do a matrix multiplication of D transpose and E. And how I'm going to do that, I'm going to say equals mmult. I'm going to select D transpose, which is a 1 by 3, times a 3 by 1 vector E, Control Shift Enter, and I get 14.5. Now notice that 14.5 is just the sum product of D and E. Whoops, let me try that again. Sum product of D and E is 14.5%. However, I couldn't do a mmult multiplying D times E because D is a 3 by 1, E is a 3 by 1. The inner dimensions 1 and 3 are not the same. So in matrix algebra, you can only multiply two matrices together if the inner dimensions are the same. So what I did is I transposed D into a 1 by 3 times a 3 by 1. Inner dimensions are the same, 3. The resulting matrix is a 1 by 1, which is a single value. So when you're multiplying vectors using matrix multiplication, you can only multiply a row vector times a column vector. All right, so that's our first matrix multiplication. And you'll notice that the new matrix, we'll call it D transpose E, has only one row, one column, and that single number is the ith row of D transpose, which is 1, times the jth column of E, and it's a sum product. Now let's do another matrix multiplication. I'm going to multiply A times B. The inner dimensions are 2, which is good. The new matrix is going to be a 2 by 3, so I'm going to select a 2 by 3 area and say equals mmult. Type in my A, comma, select my B, and Control Shift Enter. And what we have there now is a new matrix, AB, which is a 2 by 3. Now notice every single cell is filled in there. Also notice if I look at the formula bar, there's little brackets around the mmult. What that means when you see brackets across a bunch of formulas here, what that means is that was entered as an array. In other words, it was a formula entered across multiple cells. Also notice I could not delete a single part of an array. The only way I could delete an array formula is to delete the whole thing. I'm going to hit undo. Now let's talk about what these numbers mean. AB 1, 1. In other words, the first row and first column of AB is, and I'm just doing an example down here, all it is, it's a sum product really of the ith row, the first row of A times the first column of B. And if you look at this 120 number, what it really is, it's the second row of A times the third column of B. Since this is element A, B, 2, 3, this right here is the second row, third column. It's the second row of A times the third column of B. So we've talked about matrix multiplication and vectors. What we'll do now is actually calculate portfolio return using an mmult, a matrix multiplication. So I'm going to return to Excel, go to my portfolio section, and now I can rewrite, or I could calculate the portfolio return again using a new method. I'm going to say mmult. Well, here's a problem. I like to multiply these weights times these returns, but it's a column and a column. So what I'm going to do is I'm going to transpose the weights, but I'm going to do it all in one formula. So watch this. Equals mmult, open, transpose, weights, comma, return, and then I'm going to hit Control Shift Enter, and there's my portfolio return in matrix algebra. It's if the returns and weights are in column vectors, the expected return of the portfolio is a transpose W, or weights, times the returns. So in this topic, we computed, we did an introduction to matrix algebra and computed the portfolio return using matrix algebra. In the next topic, we'll calculate portfolio volatility.